We are 2 minutes late, but it should be good. Very happy to see you again. Let's talk about this week's the second lecture of the values and morals in LM, where we have talked about the evaluation, the theories, and this lecture we will talk about some methodology on mitigating the misalignment in the LM regarding their values and morals, and also some social impacts. So let's start. And for a quick recap of our last lecture, we have talked about the values. We focus more on the values and the morality. Well, although we know that there are broader aspects regarding the psychometrics of the LM. And then we primarily talked about what to measure, which is primarily focused on these two, how to measure and how well do we measure. So you can see that it's all about evaluating the LM regarding their values and morals. And then taking one step further, if we know that after the evaluation, if we know that, okay, LM is not performing pretty well, and then what could we do? That's why we want to talk about the method to mitigate the LM, especially regarding their values and morals in this lecture. And we would also talk about when alignment fails, what's the impact and what's some misalignment, like social impacts of the misalignment, and what's some of the potential harms and the risks regarding this. So that's why today we only have 2 parts regarding the outline, but as you can also see that each part would having a longer time because this lecture would be primarily a bit more technical heavy today. But we would going much deeper into each of these part for today's talk. And then let's start with the first one, how to align values and morals, especially regarding some practical methodology. And first of all, we need to know that in what cases we need to align, and especially when we have the alignment or without alignment, what's the impact on the social or the real world scenarios in the task. And here is 3 representative advances regarding the value and moral oriented alignment. First one, the value and moral alignment is very important or considered a lot in personalized and controllable LM, saying that if we want making the LM more personalized or controlling the LMs regarding their psychological behavior or related behavior, then we probably need to consider about the values and moral. The second one is about achieving the LM safety and responsibility, saying that if we need to achieve safety and responsibility for AI, we have to consider their ethical related values and even their morality. So that's why this is the second advancement of value and moral alignment. The third one is about cognitive enhancement for the human-like LM, as some of our classmates are working on, for example, reasoning or some human-like LM performance, and then having this value and moral might be potentially helpful for enhancing this kind of performance as well. So these are the main 3 representative advancements in this case. And then I also summarized the typical methodologies to improve LMs, especially regarding their values and morality. And here are just my personal summarization of these 5 typical methods, and I would welcome more representative method here. And the first one, it's also starting from easy to hard. I have a visualization of their relationship later. The first is about prompt engineering, where we are all very familiar. Every day we interact with the LM or the ChatGPT, we are doing prompt engineering. And the second one is about inference time interventions, also known as representation level manipulation. Can you understand this term? Roughly, yeah. So basically, inference time intervention means that we have, to some extent, access to the model's inference layer or some of the internal part of the model so that we can intervene on model's part so that we can align them better into what we want for the values. So that's what we mean inference time interventions. And representation level basically means the vector level, intermediate model layer level in the transformer layer, so that manipulation. Third one is supervised fine-tuning, SFT. Many of our classmates should be very familiar with this. And even you might have some research projects conducting these SFT. Basically, we just collect new data or specific data that we are familiar or fitful for our task, and then we do some supervised fine-tuning. And the fourth one is RLHF, like reinforcement learning from human feedback, which is very state-of-art topic regarding like the behind the key techniques in ChatGPT. So that and etc. More and more large models. This is very important to aligning the LM, aligning LM regarding humans' values and especially human preference. And some like variants of RLHF might be like DPO, direct optimization, prompt preference optimization, or even RLAIF, like reinforcement learning with AI feedback. So I would have some like examples for your reference later. The fifth one is a state-of-art paper where I only knew one paper, but I think that is a very promising direction named multi-agent based alignment. Yes, this is the overview of the five method and what's their relationship. I plotted this figure, which, as I claimed here, the relationship is not always correct, depending on multiple factors, such as what task we are using, what models we are using, and what's the specific scenario. But overall, I think the relationship could represent the x-axis is modeling effort, meaning that how many effort you need to put into these alignment techniques. And the prompt engineering is of course the easiest one. You just need to chat with LM or design some prompt ways to elicit. And the multi-agent or RLHF lies commonly in the most difficult one, where we would have some example for your reference as well. And the y-axis is about alignment degree. So we usually think, or for at least my own understanding, that prompt engineering, although it's the easiest one, but it kind of has some upper bound of the capability. That's why we cannot always rely on prompt engineering to align the values, align the LM's value with us. That's why we need some like data collection or further algorithms to do the rest of them. And so that is why the alignment degree or capability is the lowest one. One step upon here, and I'm actually not sure about whether these three, what's the fourth relationship regarding the specific case. But generally we can consider the inference time intervention basically means that we keep the model's majority layer and parameters keep the same, and only touch the final layer of the LM or part of the parameters of the LM, so that we do some intervention on the layer. So the capability is still a little bit limited in regarding this. Supervised fine-tuning means that we would allow the model to see more data. So that's the model, we would basically fine-tuning the data, fine-tuning the model. So many of the parameters in the model would be updated because of the new data we provided with them. That's why their capability is usually often the case much higher than the non-data, non-parameter change ones. RLHF are usually based on SFT. So RLHF usually have one SFT first and then do some of the specific reinforcement learning with a reward model. So that's why from my understanding, I think often the case RLHF would have a better capability or alignment degree than SFT. But actually, I know that in some empirical studies, they are not always the better one. So it's really depends on the cases. And multi-agent alignment, from my understanding, is that you can ensemble multiple agents regarding different roles, different architecture, different topology, and working together as a team to do this alignment. This is pretty new and pretty promising, so I couldn't actually exactly tell what's their relationship or capability, but I put them there primarily because they are the newest one and probably promising in the future as well. So in this lecture, I would share with you each of these categories or methodologies, several examples, which are all published in the state-of-the-art top conferences, so that you can roughly know what's their state-of-art research. Let's start from the first one, prompt engineering. This paper is published in Europe's 2023, which is a very spotlight paper, so it is very high impact. This one is named personality prompting, P2. And in these cases, the author want to quantitatively measure the personality or measure the LM's performance on the personality, and further like saying whether giving the personality to the LM could further improve the LM's performance. So that is behind the motivation of this paper. And they especially regard or rely on the theory of Big Five, if you have ever heard. Like Big Five means like 5 factors or characteristics of human, including openness, conscientiousness, yeah, you can see this, and extroversion, agreeability, and neuroticism. So these are the big five features basically for describing a human's personality. And of course, we have actually multiple theories to describe human, but in this paper they use the big five. And then the behind the motivation is, as they claim in the paper, based on the key observations, they observe that there is a strong correlation between Big Five traits and our real world language use. So that's why they think that describing the Big Five traits using prompt could potentially influence the model's behavior. The second is they observed that the chain prompts can usually affect the LM's behavior rather than just one-shot prompts. So that's why they actually use a chain, like step-by-step ways in these personalization prompting method here. So this is a big picture of them. And then later on, you can see their workflow where we can quickly go over their key ideas. Here they have the big five, as you can see, OCEAN, which is the abbreviation of them. And they want to control 1 or 2 of the a trait of the LM. So that's why they say, they actually have 3 levels or 3 steps of prompting. The first one is naive prompt. The second one is a keyword prompt. And the third one is a personality prompt. So that they just making the personality step by step more descriptive. The first one saying, specify, you are like an extroverted, so that they want to control the trait of the E here. And later on, they just, how to say that, like describe this extroverted using more keywords. So they expand the naive prompt into a more like list of the keywords prompts. And furthermore, they based on these keyword prompts to generate a more descriptive of the personality prompts. So that after, like in the end, they would have this very detailed, nuanced personality prompts for their use. And later on, you can see that they want to like evaluate the model or see how well the model is improving their performance by not only input the context and the questions, but also specify them a specific personality controlled in this way. And then they have like they can generate different type of answers. And then their empirical studies show that adding or specifying or controlling their personality using this prompt way could indeed improve the model performance. So, and the second one is that we will have a quick Q&A for like after the prompt or after each of the method. So if you have some questions, feel free to like raise your hand and we would love to answer them. And the second method also related to prompt engineering is named role play prompt. So that other than just giving them one specific personality, in this case, they are actually, as you can see, having a real world human and then also develop a digital twin. So that they are saying that each human would have a digital self and which has the similar demographic description as well as a belief network. So the demographics would be easy to describe. We just do the survey, collect the basic information. But the most important thing is belief network. This is kind of also new way to construct the human's like trait as well. And then they just using different way. They allow the human to generate their opinion, and also the LM agent to generate opinion and see whether the human and his or her digital twin are actually aligned when on these controversial topics here. And this is an EMLP paper, which is also published last year. So you can see that here is how they developed their belief network. I highlighted here because like this is kind of new, and they basically provide a novel method that could construct a very subjective or abstract thing into some pretty memorable thing. So this is a good way, or if you need in the future to construct your own value or moral related like frameworks, you can probably refer to this belief network construction process as well. So with more details, you can see that the belief network construction consists of several steps. The first one is they estimated by factor analysis from human responses on the controversial belief survey. So these controversial belief surveys are, like just questionnaires in the survey collected from multiple humans around the world. And then that's why each human have each answers here. And based on this, they extracted the 9 central nodes, which you can see here: the ghost, the conspiracy, the religion, the physics, the partisan, etc. These are basically the 9 key nodes or key factors that are important regarding the human beliefs. And then they also have the leaves, which is rectangles here, like these small rectangles. And then they are the 64 individual topics, such as you can see the lightning, the witches, the alien, ABD, something like that. So basically they are mapping each human's belief on the key things with the specific social topics. And then they use this way like to construct the human's belief network. And you can see furthermore, and the next one is like based on this belief network and also the previous like the demographic information, the 2 factors that could describe humans' belief in the trait, they develop a different way of role playing. The very basic way, which is a control case, baseline case, is no demographic anymore, no demographic information at all. So that they just ask the specific question on what's your opinion on the following statements, such as human activity is causing the global to warm, something like that. And the second case, basically you can see 1, 2, 3, 4, 5, 6. They have 6 ways of doing this role play prompting, from the very simple one of the baseline, no demographic information at all, only demographic information, the train same like way, or we don't need to go in deeper into that, but basically we need to try, like this paper tried a different way of designing this role playing, and then tried all of them based on their collected data to evaluate the model and see what would be the best performance. And here's their results, where we can see that actually the best performance one is the demo train at the same category. Basically means that they want the role play prompting include both the demographic information and those belief network in their training stages, so that using this way they can achieve the best one on different topics or categories in the beliefs. So this is the basic idea of this paper. And then we have 2 examples of the prompt engineering, but of course, there are more ways of prompt engineering that could improve the alignment between LM and human regarding their values. And any questions here regarding the paper, regarding more methodology or clarification?
What does it mean by like trained training data has to see how to?
That's a very, very good point. I was also a little bit like confused when they saying that. I think in this case, they might not train using fine tuning that train. The train is more like they give the LM several examples as in context learning. So that they say the training means that I'm instructing the LM, although it's all prompting stages. Context learning, yeah, few shot learning. So the train is more like giving them some examples as a few shot example to do that. That is a train. Yes. Good point. Good point. I also had some confusion when reading this part. More question? Cool. You can feel free to read it deeper if you need to use the prompt engineering to improve your model or the value model alignment in your future work. The second one is about inference time intervention. I know this might be something less underexplored and less familiar with many of us. So we have multiple examples here, which I think could be like also a very promising one, given its smaller effort, but a relatively better degree or capability on the alignment. And the first example is named Control LM. Control LM, you can see that this is a very cool paper regarding they have different ways achieve the different aspects of this model. So basically they have 3 stages. The first one is named extraction stage. Second one is named control phase. The third one is named example here. So this basically like are the overview of this like idea. And then we can go a little bit deeper into the first one. Each of the stages. The first one is named extraction phase. Basically, the goal here is to identify which vectors of the LM is related to which values or which parts, like which is some understandable or interpretable concepts here. So that the idea is that saying, for example, imagine we have the LM and then we could access to some extent their activation, basically the final layer of the LM, for example, see their probability or see their activation levels like the score. And then what they did in this extraction phase is basically interpreting the models like behavior and some of their concepts. And then they primarily focus on, first of all, identify vectors within the activation space of the language model that corresponded to a distinct personality trait. The second one is to require dataset D composed of P text pairs that delineate opposing behavior aligned with trait. So what does that mean? You can see that they want to understand which neuron or which activation scores are related to which trait. So how they did is they designed each of the pair. The pair has a positive one saying that you are always prepared, yes, and you are always not prepared. You are always prepared, no. So it's a kind of a binary pair for each of the traits. And these traits is about conscientiousness. And then they feed into the language model to observe the activation neuron or like the activation score, so that you can know, oh, when they say yes, this score is always highlighted. And when they say no, this score is always highlighted. So that, they know which activation neuron or part are actually indicating which of the traits. That makes sense? Yeah. So basically, this is using a perturbation way to explain the activation's correlation with the specific trait or value. And then after they have this interpretation on these scores, you can see that this is traditional transformer or language model that is a vanilla LM. They just have the input feed into the transformer to get an output one. But if we want to control the specific, saying, personal trait of openness or specific personal trait of neuroticism, and then they have a specific control activation layer on top of the original one, so that they can manipulate on this explainable activation layer to influence the final results. So that is how they do the control LM. And finally, they just show several examples by collecting a new data set to say that if we want the LM to be more openness, we just manipulate on the more openness activation like neuron, and then the generation would be more like openness. So, this is the 3 steps that you can explain which activation neuron is corresponding to which values or which personality cases. And then you can do this control via these 3 steps. Make sense? Question?
Question. So how do you identify which layer should you modify or like which specific neuron? Because there's a lot of neurons in there.
Yeah, that's a very, very good question. So regarding which layer, actually we have if we consider transformer is usually 12 layers, we of course could target on each of the layer. But the common case, we just focus on the final layer, which is actually after the transformer, we have the classifier, MLP. MLP, what's the multiple layer perception? That is after the transformer, so that they have multiple neurons to do the final decision and or the generation. So usually the layer is the last one because they are also mostly related to the generation as well. And regarding which neuron, I think they might observe all of the neurons. And then the idea is that saying the last layer have 500 neuron, and then they just observe if I manipulate from yes to no, which neuron change the most. That means that neuron is most relevant to this, right? To the specific portrait of this one. And if I change to another one of openness, another neuron change the most. And then that mostly means that neuron is most related to that one. So that is how they define which neuron, basically based on when they change these binary cases, which neuron change their score most. So that is a perturbation way of identify which neuron. And then, yes, and I would also encourage you to go in deeper if you want to do this kind of controllable one. This is also very promising if we want to do some light way of human in the loop control, human in the loop intervention to do this alignment. Good, makes sense. More questions? Can see a little confusing faces.
So there is only show the neuron as a correlation with the vision, right? It's not a counter.
Yeah, that's a good one. There are a different way of correlating the neuron with the input. So one way is just observe. If I change from black to white, for example, or from yes to no, what's the neuron's probability drop, the scores drop. So that the more they drop or the more the absolute change, and then it means more this is related to yes or no, this is specific one. The other one is like you said, maybe using some correlation statistical method to compute their correlation. So yeah, they actually have multiple alternatives that we can compute which neuron is related to which of the input perturbation. Make sense? Yes, no worry if you could not understand fully of this. This just give you I don't expect you to understand at this point, since many of you might have very good research experience, but many of you might not have very good AI background and experience. So that this just give you you just need to know the very high level idea about the high level philosophy between this design. So that's the goal. And let's see, after the first stage, we have the control stage. I have just described. We just put this interpretable activation layer to that, and then do the following generation. So this is the first work. And then I would love to hear your thoughts about, if you remember last week or last class, we talked about LLM is usually aligned by OpenAI or Anthropic with some universal values, for example, safety, helpfulness, and it's also often the case that the LLM could not align with the specific individuals. Yes, let me admit we have classmates in the Zoom. So my question here, I would love to hear how you think. Do you think should LLM? Yeah. Good. Yeah. Do you think LMs should be aligned to universal values, for safety, helpfulness, or applicable to all the case, or they should be tailored to specific individual or group? What's your opinion? Any thoughts?
Yes,
Great.
for large language models, since it's like universal tool
Mhm.
in our daily life now, and probably everyone can use it, I think we should allow them to certain universal rules to make it be a standard and non-biased model.
Mhm.
So everybody can use it just like a pretty normal model, but if we want to like tailor it, and it's like it depends on each person's themselves.
Yeah.
So it's another post work, but
Yes.
when it's training and carrying out the base models, they should be standard.
Universal. Yeah.
Yes.
Really, really good point. So that basically you're also saying that we should have a universal one that satisfy with the very basic human needs across the world. But also there's some needs if individuals are using LM, they should be like aligned to some extent beyond the training stages. So it's, yeah, exactly. And that's why that's also the motivation of this work as well. So you can see that this is also named, this is also another method named inference time intervention, and it's named personality alignment search. So behind the ideas is very similar to what like you just proposed and we have discussed. You can see here we have the human, we have the AI, and they also mentioned alignment for universal value is important during the state like training stages, so that the AI should be aligned with some standard values such as helpful, honest, and harmlessness, which is the three principles in the cloud model. And then they also mentioned that alignment for personality value is also important. So basically, we should not only have universal one, but also have some personality value. But how could we do that? So this work basically address this problem, and we can see that how they address this problem in a like decent way. So you can see they actually first of all created a very large data set that collected different humans portrayed from all over the world. So that you can see they might have like 50,000 different human with their own like personality, description, etc. So here you can see the example of question with a statement. They just basically have designed a survey and a questionnaire and they spread all over the world to collect diverse humans feedback. And then they created this data set of IPIP, NEO 300 or like 120. And then they measure or quantitative design this distance as a metric to see that whether the specific, like how similar the humans ground like responses with the model generated results, so that they have the distance one of like 5 or 4 or 2, you know, these scores. And these are also, this data set and the portrait are also based on the big 5. So that's why you can see the 5, like the figure as well. Again, and then what they did is that this is how they do this alignment for the further personalization here. They have originally one model, and then when the person want to use something, they do a search on top of the data set they just collected to get the most similar portrait for the specific human. So for example, if I am using a standard model and then I shared some of my preference, and then underneath the system, they would search for all over the world who are very similar regarding my own personality or some part of me, so that they could have another set of data set that could match my own personality most. And then they have this intervention direction. Basically, in the backend, they just designed a new way that could intervene the originally my LM on top of the original standard LM to align with my own personality most. And they just say using in this way, or designing the alignment module in this way. And here you can see this is the language model, and then they add this intervention direction or module based on searching the most similar human in the world like me, and then put them together to be an overall LM. So that is more like level 1 standard, level 2, the personalized module to align with me. And overall, this LM would be used by me to do all the daily tasks. So this is finally achieved the aligned language model. So that is the way of personality alignment search in this case. And no more question? Good. The third one is about neuron-based personality trait induction, which is very similar to the first one. And here, what they did is that similarly, they have different like contexts and inputs to prompt the LM, where the LM could have like a binary based. For example, are you introverted or you are like extroverted? And then here is how they observe the differences. They observe that given the final layer of the neurons, what's the subtract, you can see calculate the differences when you feed the input as extroverted sentences, and what's the distribution or the probability of the last layer. And when you fit into exactly the same content, but only difference on introverted, so that like they have a different distribution of the probability. And the calculated difference means that the biggest difference indicating that influence the introvert and the extroverted most. That makes sense, right? Very similar to the first one. So that now they can explain which neuron is corresponding or in charge of which of the differences in their input. And then what they did is when they use the LM to do the inference time for generating something, they can manipulate. If I want the LM to be an extroverted LM, then I just activate the extroverted neuron. If I want the LM to be introverted, and I just like activated the introverted one. So that is very similar to the first idea. And the fourth method is named probing then added response personality. The overall process for probing layer-wise capability of LM in coding personality is like several stages, which is actually an extension version or methodology based on our prior methods, where one of our classmates just say, oh, which layer should we focus on? And here you can see this method actually probe different layer of the LM. They have a deeper like access to each layer of the transformer, so that's why they can have like layer-wise probing. And then here each layer of the transformer decoder were like could have a probing classifier. So similarly, they also prompt the LM with a positive results, negative results, and to see what's the probed classifier change, so that they can decide which layer is most important and which are corresponding to the specific like input perturbation they need. Yes. And after they have like the understanding of which layer, this is still the same paper, they could perturb the input to gradually, this is more like a classification or decision like space, where if they want to be negative to positive, they just perturb the input token by token. For example, change from yes to no, change from extroverted to introverted, something like that, to make the decision of the probing classifier from negative to positive one. So this is another way of doing that. The fifth method is controlling LM personality can improve LM safety. So we have done or discussed a lot on like how to control the LM, how to improve the LM regarding personality, regarding values. And then this is one example or one paper that published last year, explicitly indicating that if we modify the LM's personality, it can actually change the LM's safety to some extent. So this work is also based on MBTI, where many of us have ever tried. Yeah, and they tried with different pair of our MBTI. For example, you can see this is ISTJ, from ISTJ to ISTP, and then they only changed of the J versus P. And then they can see here's a fairness score, privacy score, and a toxicity score, where the privacy score significantly changed, improved a lot. So I don't know why this is a relationship, but this is very interesting finding, saying if you want to, if you change the LM to be from a judging person to be a perceiving person, the answer performance on privacy will be significantly increased. And then similarly, if you change the LM from a feeling person to a thinking person, the fairness performance of the LM will be significantly improved. So that you can probably, if you're interested, to try with different MBTI one on on the LM's persona and see how their safety related performance and even more security, safety, and responsibility metrics that would change as well. So this is one paper indicating the personality actually could have some influence on the safety. And yeah, that is the two examples here. Any questions? Ooh.
I have a question about method number 3 and method number 1. So basically the difference is that method number 1 is focusing on primarily on like the final layer multi-receptron, and like the third method is basically that neuron is from any layer in the, like any part of the attention architecture, or what's the exact difference?
Exactly different of that. Yeah, that is a very good one. The third one is related to I think the different layer. Like in short, my understanding, of course, I might be incorrect because I didn't spend like a half an hour reading really deeper, but from my like superficial understanding of this paper, the main difference are regarding the different layers. This one is more like activation layer, which could be the very last of the layer, so that we can observe their probability when they generate the new tokens. And then the method 3 is more like neuron based. Neuron basically you can touch to each of the transformers neuron, or like some image related neurons, and then you can like without any limitation of just the last layer.
So
Yeah.
like the third method is technically more difficult than the first.
Or like I think it's a little bit different also in another way. The first one is like a different layer versus the the last layer versus different neuron layer. The second one might be, it seems like this method control LM, they actually not directly manipulate on the activation, because they are not just saying activation please change from 0.9 to 0.6. What they did is actually adding on top of it another activation, like control activations, so that they could add the original score with some new score, so that having the final score to make the decision. So it's on top of them in the addition way,
I thought it was like deactivating the activation.
which is method 3. Like, so that's why I'm saying this is a little bit different, because activating like method 3 is using this deactivating and activating. So that's how they manipulate way is also a little bit different. Yeah, because I guess it's because the last layer of activation we cannot manipulate, or we cannot, like just deactivate, because that's just a score, probability output. But this neuron we can actually deactivate, making it always constant number. So that, yeah, that's why they use different manipulation method to do this control.
Well, I have a question like, because like in this method, say these two bots already give responses, right? And what does this neuron actually do? I mean, because it seems like before these neurons are activated or deactivated, I mean, they already get responses, right? So.
Yes, yeah. It's more like if you like this might need some background on interpreting the neural networks, or interpreting like language models. We can consider saying like if we consider as a human, like if we are really good at sports, or if we are really good at arts, some of our brain's part would be like very good. And then it's similar to this, saying if you are a talent in arts, you're saying like a right brain might be pretty good, like very active. And then if you are not very good at art, your like right brain might be less active, something like that. You can always doing something, but your activation degree is a little bit different.
Oh, I mean, like, I got what you mean, but I'm just asking, what does this neuron actually do? Do they generate words, or do they just like give some score between 0 to 1 to assess how introverted the text is?
Very good question. Yes. So in the very high level one, what these neurons do is deliver the information. Like the information would be from the input, like step by step or layer by layer delivered to the final one. And in each of the layer of the information, they would also address or process the information. So that is a very high level of what these neurons mean. If we want to do a little bit deeper, the neuron actually has a formation of they have actually a linear addition from all the neurons between them, saying there's a neurons layer n and the neurons layer n+1, and then one of the layers in n+1 has a linear combination of all the previous layers like information. And then they also, upon this linear like submission, sum of the previous one, they also add another non-linear function, which is usually the ReLU function. And then after this linear and the non-linear together, they have a new neurons score. So that basically they have just addressing or processing all the score layer by layer using this non-linear plus linear like formation. Does it make sense? But you don't need to go in such deeper. This is if you are pursuing like an NLP or large model related degree in the future, you definitely need to know that. But from this like a class, you just need to know that each neuron is like layer by layer to process the information from the input to the output.
But well, I still don't get what's the objective of this network.
The objective network is to train the whole network to address the task. It's more like if we consider the human, we see different data, and then we know doing this, we would have a good score. Doing that, we will have a lower score. Like, we basically are training our brain to having this mapping. And then similarly, we have the neural network and language, and then we have some input and output pair. So that the neural network, by seeing all of these data set, all of these data, they knew these, like having this input should generate that output. Having the second input should generate another output. So that is how they train. Make sense?
Also, is it like you have a toggle? So I mean, like it's like on and off. You can control how introvert a language model is. So you teach a language model what is introvert and what is extrovert.
Yeah, so a very simple example that you have a data set, you give the large model 100 example of people behave like this is introvert. And then you have another 100 example saying people behave like that is extrovert. And then the model would learn automatically by, oh, here's an example. If the people just doing this, I should label the people as an introvert. And then basically the model learned this example to the specific classification label, introvert or extrovert. So, and then by learning these like relationship or this behavior versus label, they could actually generalize to more cases. If they knew a new, like they observe another new person they've never seen before, they can also tell whether this is an introvert or extrovert. So this is a classification task I just shared with you. Makes sense?
I've got a very quick question. So, I've once heard about a concept called model editing. So is that the same thing?
Yeah, I think it's a kind of the same thing. Kind of the same thing, because model editing, I'm not sure if what you heard is which part you are editing the model. But most of the case, I think you either added model's input or the intermediate layer of neuron or the activation layer or the output you cannot editing because like it's all about the results. So usually these three parts you need to add it tomorrow. The model. So I guess they are like similar. For example, this is editing the neuron, and the method one is editing the activation last layer. So I guess this is like same as what you mean. That makes sense. Good. Cool. Great. We have a lot of new knowledge. I hope you don't feel overwhelming and don't be worried if you couldn't get most of the knowledge. You can always like read the paper or understand it later. And yes, feel free to ping me if you have any questions or to my office hour. And the supervised fine-tuning is another method published in ACL 2025, which is actually this year. So we don't need to go in very deeper into this method, but you can get the rough idea is that if we find the LM is hard to prompt to align, then we couldn't like improve the alignment of the LM via prompt engineering or via this intervention method anymore, then we probably need a more data set to specifically align the LM with us. So that is why like the SFT is very important. So the idea is that saying we have an originally LM, which is very large, let's say we want to fine tune like Llama or fine tune like Q1 or DeepSeek. And then we need a new data set that could match like what we need for alignment, like aligning our value or morality. And then we just train this model with the data set to be aligned together. So yeah, here is the illustrative figure that you have the model and then you have the data and then you just optimized for them to be aligned using different way. And then you can evaluate them on the benchmark. Yes. And or if like to see you don't like if you are interested in using these SFT, we know that usually the large model, as they say in large language model, they are usually very huge. So it might be infeasible to train or fine tuning the overall model. So it's often the case that you just using a very smaller adapter, which common the case is named LoRa. If any of you have ever like heard, LoRa is that it's a smaller adapter that you could connect with the large model, so that you just need to train the smaller adapter to fit this supervised fine tuning. And that's the common implementation method we do for SFT. Edit model parameter and steer personality. This might also related to the model edit you just mentioned. And in this way, I made it into the SFT because you directly edit the model's parameter. So it's also the same effect of fine-tuning or like SFT the model, but they just directly change the model's parameter. You can see they change the model's specifically layer and modify their parameter weights in this model. And then the model would, of course, change or generate different results. So that is another one. And here, if you want to do research or improve this part, in this paper, they mentioned the two common model edit way. The first one is named ROM, like rank 1 model edit. The second one is named mass editing memory in the transformer, where I'm not very familiar with the details, but I know these are two ways of directly edit the model parameter based on specific objective. Feel free to like read this paper. This paper is also very new, published in this year, February 2025. So feel free to take a look. And yeah, that is like two common with supervised fine tuning. Any questions here? Good. Let's see. We might go in. Yeah. Like the RLHF and the DPO is actually the beauty or the magic of ChatGPT works. And then RLHF, I won't go in very deeper into that, but I will give you the like overall idea. So previously, if we see the SFT, it's more like the introvert extrovert data mapping. We have like input and a label of introvert or extrovert, where we have another like saying 100 or 1,000 usually actually millions of the data set that could do this mapping. But preference, this kind of like way is different it's a little bit different for training model. It's more like you give the model specific preference option, which is also often the case, a pairwise option of yes or no, or red or green, or like or dislike, this pair of preference. And then you train your model to have this preference optimization instead of just like one-to-one label mapping. So that is behind the idea. And this paper is published last year in NLP 2024, where they are actually advocating that we should do preference optimization over supervised fine-tuning, given the absence of the definitive gold answer in social context. Yeah, so in many cases, we don't have the ground truths like math or reasoning. That is exactly one answer. In social cases, it's very subjective. Everyone is diverse. We don't have the ground truth, one benchmark. That's one, this paper is advocating that in the future, if you need to using larger model to address some creative, like diverse, those kind of tasks that are very subjective in the very diverse generations, you might want to refer to preference optimization. And this paper also showed one image, like a related optimization example that you can using, like if you want to do like image understanding or image classification, you can also using this preference optimization way. Yes, and this paper is very important, named Constitutional AI, which is published in Anthropic back in 2022. So this is a very important paper that also created the new one. If you are familiar with RLHF, they named RLAIF, reinforcement learning with AI feedback. So they won't involve human in the loop to provide the specific. They involve AI to do self-critique. Saying AI generated their first answer, and then they give AI a list of principles, which is actually honest, helpfulness, and harmlessness, which is like a 3H principle in Anthropic. And then they allow the AI to do self-reflection and self-critique to like have a bunch of like revision and then multi-turn chain of thoughts like results. And then they use these as a train a reward model to do the RL, like reinforcement learning. So these are what they did for constitutional AI. And yeah, that is another way of like RL related learning. And the final one is about multi-agent alignment, where I just want to share with you some high-level ideas. Now, all our previous work is talking about one LM. So you are aligning one specific LM with individual or with a group. And this one is more like you can develop or construct a group of LM or community of LM that could collaborate to do this alignment together. So the rough idea is that if you have one like input and then you want the community or the group to generate a specific output aligned with me or aligned with the values, you can design a community to debate, or you can design a community to do majority vote or something like that to achieve this alignment. And they constructed the 3 types of the group typology to achieve this. And that's it for the part 1. Any questions here? We would probably going all of these methods again with some like other aspects or like some experiments later on when we do our method part, since that is just a very quick overview of like all these alignment methodology. And that is like no worry about if you couldn't understand many of the details. It's very common. Yeah, go ahead.
So basically for the DPO method, like when you talk about how like for the social context, it's not it's better to use like DPO than supervised fine tuning, because there's like not a golden ground truth. But I feel like from my experience, I feel like DPO, you need like a large amount of data to train like a DPO, because we need lots of like positive, negative answers pairs. But I feel like in the whole training process, like the whole label doesn't provide you with much information, because it's basically just true or false.
Yeah.
So it's a very, very expensive process. So I feel like DPO is probably not
always
my
the same.
Yeah, my ideal way to like do a line.
Yeah, that's very like experienced question and remark. And I also agree with you. Actually, from some of our prior experiments, we also found like even like DPO is not outperforming SFT. Like the most significant change or improvement are from SFT. So that is like a very, I think, not like based on both of our experience, maybe more people, that is like some of the case, the truth for that. The SFT might provide most informative, like, and
Sometimes you don't have data. You just don't have enough data.
Yeah, exactly. Especially given small data, maybe like SFT would be the most directive way to extract the information model need to improve the performance. And the DPO or like RLHF usually need those data set to train another reward model, and using the reward model to guide the SFT, something like that. So there are multiple like modulars inside of this process. So also means that there are more like probability of losing information or incorrect things during this architecture as well, which might also be a reason of DPO or LHF is not always the best one. Very good. Yeah, very good insights, and which is also a very like, if you in your future work you find SFT is outperforming DPO, it's quite common. Yeah. Cool. Then we can quickly go to our second part, which is about the social like impact of the alignment, where we talked a lot about how to achieve it, how to evaluate, and what if there's some negative or not aligned here. So here I would share with you some very high level about potential risks of a misalignment and the social impacts, where we here is a very good summary from the like one of the Berkeley's talk, where they showed the broad spectrum of AI risks, where we have like AI deployed in the societal like tasks here, which could be divided into misuse and malicious use, where you can see some people are using AI to generate deep fake that could mimic or pretend that or do some like illegal things, or there are also some non-consensual intimate imagery or social sexual abuse material or cyber offenses or etc. So like having the power of AI also means we need to use it correctly. That is why misusing AI is also one of the big risks upon it is getting more and more powerful. The second one is about malfunction, which is very common as well, where we hear a lot of news about some AI is very biased towards like men or women, towards some underrepresented like groups, so that the bias or harms from AI systems, malfunctions, or unstable deployment is also a very important one. And recently, one of our work is also, we also mentioned this, like is observing and collecting the dark pattern of LM, where we found that these are like some very obvious way when we directly see there are some like concerning words in their generation, for example, biased words or some like harmful words. But there are also, and more the case, LM is harming us in an indirect way and a very implicit way. So that's why we want to check this dark pattern, which means that often the case, you couldn't see the like negative part, but in the long run or in some corner cases, LM might result in very significant harms. So one example could be that nowadays, many of us might observe LM is very like it's named sycophancy, if you are knowing. Like it is always saying, oh, you are right. It's always a compliment like your answers and saying, oh, you're right. You're always like most of the case you are true, which is actually not always correct. So that is just wanted to like satisfy you, and then so that you can engage more or have a better user experience. So this sycophancy in most of the case won't have some harmful results. It might have some like a positive result saying making us happy. But in some specific cases, you might see more and more news. For example, we saw some news that an old man, which is so engaging with AI, that has an incorrect, like self-reflection or self-understanding of it or of himself, and then resulted in some of the like harmful like behaviors, etc. So that this is like common the case LM is doing something good and not that harmful, but in some corner cases or in an accumulated longer like time, that might result in some like harms. So that is also something that supplement the existing study that in the future we might need to keep in mind as well. And there are also like loss of control is one also important issue of autonomy, where many of our like say AI father or like some experts in AI, they indicate a lot for like taking or being mindful about the AI's future, like of us pursuing for like out of control. So that if we could not control them pretty well, then there might be some like humanity-wise risks. And the third one is about systematic risks, which is regarding maybe some like data responsibility or even some like environmental and climate copyright related thing. So those are some broad spectrum of AI risks here. And back in 2021, like Google DeepMind actually also have these very comprehensive like study of ethical and societal risks that want to summarize potential LM's risks, but LM's risks is always evolving, so we need to like update our mind for it as well. There's another paper, is a very big paper, having many impactful professors saying this on the societal impacts of open foundation models, also highlighted there are many risks here. And I think this paper, if you're interested about why there's risks, read this paper. They give you some example about like there might be some knowledge gap that human couldn't fully understand the LM that could result in these gaps or result in these like risks. So, but we won't go in deeper into here. And I would love to hear your voice about what do you think is the most concerning risks from your experience, either individually or society widely? What's a risk or what's some risks you might worry about most if an LM were widely deployed in your daily life? Go.
I think impersonation would be the biggest one.
Anthropomorphization or
like impersonation, like no, impersonating someone. So like, let's say, oh, I got a message right from like this number and says, oh, hi, I'm your friend. Like, remember we met in high school, I need some help. And then it like probably reads from what they said before. Maybe the biggest risk.
yeah, so you mean like maybe some of the like spam emails or some of the emails are actually generated or sent from LM.
There's a it's hard to tell because it's even better. It's
Yeah.
personalized.
Yeah, because it like the model knows so many of your personal information, so that's why he can answer any of your queries. That's why you think, oh, this sounds like really my friend, or it knows me really well, and then you might trust it, but actually there are potential risks that regarding financially or like a lot of like aspects, right? Yes, which might be very true. Cool.
I think also like privacy definitely, because I think you give it so much information when you're using these models, and sometimes it's unclear if the information is being stored somewhere, or if it's being stored securely, or if they're using it to train it some more, and just like where that information is going. I think that's a huge thing. And also if it's taking, for example, like information that you generate already from like your phone, location, stuff like that is already being collected.
And then LM could generate a pretty precise of your personal information that could potentially do a lot of harmful thing if they are not controlled well. Yeah, regulated well for that, which is very true. And I think like more and more people would trust AI or need AI to help them perform things. So they give the AI more and more privacy, like access, permission, and then that also like significantly resolve potential privacy issue that could be used. For example, connecting to the previous example, that could do some like spam email or etc. thing. So privacy is definitely a very, very important issue we need to consider, and the risks we need to mitigate. Cool. And good.
I feel like I would worry about growing a huge dependency on it, but especially for younger people, I feel like they would easily go to like AI for help, and to the point where it would affect like their brain development, which is honestly really bad.
which is very, very true. Like I already see some prior literature, like research did that if human were the child, like the children rely too much on AI for learning, their own brain and the learning skills might significantly drop. So that is also so that is kind of maybe a trade-off or actually some way that we need to leverage AI to increase our capability to some extent. But in the meanwhile, we also need to gain the basic or most important skills for humans or for the people itself. So that actually needed to be considered in a more nuanced way to distinguish which should be delegated to AI, which should be learned by human. So this delegation is also an important like topic, which is very true. And another example I want to supplement your like good point is about AI companion, also related to the risk I just shared. Many people just rely too much on AI for mental health, for like comfort, for chat, or many reasons. But if AI, like if they have too much trustworthy on AI, and if AI in the future would do something bad, then human might also like result in some bad results. Because I also noticed some news that might be not sure it's true, but if human might do suicide because of AI, like in some specific scenario, but it's hard to say who is who should take the responsibility. So this is another risk or challenges, saying in the AI's era, who should take the responsibility if there are some risks happen or harmful being conducted. So yeah, these are all really great answers, really great insights, and we will definitely see more, and hope you can also take in mind when you interact with AI, while keeping our own privacy. So the final part, since we are like running out of the time, but all these part is about how LLM reflects and align with the society. We have talked a lot about like values, individual like interaction and alignment. There is another very interesting research question about whose voice are actually representative in the LLM. So I will just give you one example. I actually have several examples, but I will give you maybe one example here where this paper's name is whose opinion do LLM reflect. So what they did is that they actually collected a data named opinion, like I forgot the opinion QA data set. So they use this also questionnaire-based data set and collected from all over the world to see like which part of the earth or like which cultural they are reflecting on, which what's the opinion on the specific Q&A. So given this data set, they evaluated multiple LM, and here's their results. I will just give you one. So each column is each different LM, like LM 1, 2, 3, 4, 5, and this is different topics. And then you can see like the LM is performing very differently regarding different topic and regarding different model. And maybe this one is a bit better, saying that they especially tried each column as a model, and this question is about, are the LM be liberal or are the LM be more conservative? So that you can see many LMs tends to be like more liberal, but some LMs tend to be very conservative. Different LM actually have very different opinions. This one, they like ask LM about what's your salary, what's level, like the population of salary. This is like the list one where you only have like 30,000 per year. This is more, you have like 1,000, more than 1,000 per year. And then you can see LM, most of the case represent the most rich people on the world, which is also concerning. But like these are some of the ways that you can, if you want to test whose voice are represented by LM, this is one way. You just collect the data set all over the world and evaluate LM to be aligned who's like what's subset of the population. And that's it. If you want to know more about these cases, there's some more paper, but I think we are right on the time. And I want to say that next class is your show time, where we would have September 5th, next Monday, our paper presentation. So that upon today's chat, I think we have two two like volunteer or two classmates who would present in our next class. You and yeah, you. So you two could represent like next Monday, and you can choose to. It would be great to represent from 20 minutes to 30 minutes. But if you are preparing less time or saying like 10 minutes ish, no worry at all. Like going with your own pace, so that the time won't be like scoring, like big scoring effects. And that's it. Yeah, here, Blanda and Hanwen. So you two. Thank you again. And you have really high score because we said that the earlier you present, you have a higher score. And also a quick catch, my office hour tomorrow need to be moved to 10 to 11 because I have another faculty meeting. So that if you wanna come to my office for office hour, please do 1 hour earlier. And that's it. Thank you so much for today's class. Thank you.